Here's the question then. Got it in summary form here. Show that the tangent is this. So let's have a go at part A. P is on C and has parameter P, so P will have coordinates 2P and 5P cubed. Okay, so let's get the tangent then at the point P. So this is part A. So dx dt, first of all, is equal to 2. dy dt is equal to 15t squared. So dy dx then will be this divided by that, 15t squared over 2. Okay, there's dy dx. So at P, dy dx then, the parameter is t, so at P the parameter is P, so dy dx will equal 15 P squared over 2, and P has the coordinates 2P, 5P cubed. So here, tangent y minus 5P cubed then is equal to the gradient 15P squared over 2 times x minus the 2P point. There's the tangent at P, there's the gradient at P. So what did we need to show? 2y, so let's just move the 2 up. So we've got 2y minus 10p cubed times that by 2 is 15p squared x minus 30p cubed. So 2y is equal to 15p squared x. Move this 10 over and it'll be minus 20p cubed. So there's the tangent at P. Yep, that's fine. Minus 20, yeah. Okay. The tangent to C at P intersects C again at Q. So this tangent intersects it at Q. 5Q cubed. Okay. Given P is 1, show that Q. So the y value at Q will be 2 of these, which is 10Q cubed is equal to 15P squared x, which is 2Q, minus 20P cubed. So P equals what value? 1. P equals 1. Let's see what we get. We get 10Q cubed equals 30Q minus 20. So, okay, divide by 10 all the way through. That would get Q cubed is equal to 3Q minus 2. Okay. So Q cubed minus 3Q plus 2 equals 0. Okay. So if we put Q equals 1 in here, so f of Q is equal to Q cubed minus 3Q plus 2. When does that equal 0? Well, let's put f of 1 in, I think, is what it should be, shouldn't it? You can see that easily. 1 minus 3 plus 2 equals 0. So Q minus 1 is a factor. Okay, so what do we want to show? Part B. Given show that, and what? Find the value of Q. So here Q equals 1 is one solution. We could divide it out and get a quadratic, but But we found the value of q. So that will be fine, that's what we found. So I don't think it's strictly necessary to do a lot more with that question. But here we have factorized it. So we've got either or, so we've got all the solutions. So it doesn't say, question doesn't say find the other value of q, find the value of q. It doesn't say find a value either, does it? So we ought to find the other value then. So we'll do some division and work out the other value, just as the solution suggests. So here, q minus 1, let's divide that into the q cubed then. Minus 3q plus 2. And we get q squared. Multiply through and subtract. 0 minus q squared is q squared. Whoops. Minus 3q minus nothing plus 2 minus nothing. Then it's going to be plus a q. That will give us q squared minus q. Take that away. And we end up with minus 2q. Which I'll need to squeeze in slightly. So we get that minus that, we get minus 2q plus 2, and then I'm going to put minus 2 here, and that will cancel that. I'm not going to write that down. So here we've got this. So if q is equal to q minus 1, and then this quadratic is q and q, and then we've got two ones. Minus 3, so it's going to be minus and minus. So that was fq equals 0 when, and now we get our two solutions. Q equals 1 or q equals 2. And that's indeed what the solution said here. Let's have a quick look. Minus 2. So that must be plus 2. Oh, that was a plus. Because that's a plus, isn't it? So that would be a minus. Apologies for that little mistake. And that's the question done.